Hey guys, and welcome back to 10 parts for 70 marks. This is video number 5 now, I believe. And I call it Year 11 TRIG, and it's just the extension 1 TRIG that you learn in Year 11. However, I'm not going through your things like your double angle formula and your half angle formula, etc. Only because I find it pretty straightforward just copying a formula out or some sort of proof to finding that formula or proving that formula. But what I thought I'd focus on is, in this video, equations in the form of this here. And the reason I really wanted to focus on this is because for some reason it confuses a lot of people. But once you know it, you'll find it quite straightforward. And it is nearly in every HSC exam somewhere, okay? A lot of the time multiple choice. So, bad news is you have to be able to remember those 4 formulas in the yellow highlight there, as well as this formula here and these ones here. So there is a bit there. However, let's just analyze the formulas for a second. Just remember that when sine is at the front, it's sine in your form of an equation. When cos is at the front, cos is in the equation. And then it's the opposite sign. So it's the same sign for sine, which that could be a good little memory jogger. Same sign for sine. Plus is a plus, a minus, and a minus. But it's the opposite sign for cos. And why? Because that's how I can remember it. So plus, minus, minus, plus. Same sign for sine, opposite sign for cos. Why? Cos. So hopefully that'll help you remember it. Now, all that's happened over here, and this triangle should help you try and remember these last 2 formulas. If I put my alpha on my angle, tan is opposite over adjacent, so B on A, then to find the length of R, the line here, I'm just going to use Pythagoras. So that's all they've done there to get that formula. And then they've literally written tan alpha is B on A. And then I've just made one extra little step here and said, well, I know that tan is sine over cos. So really, it's sine over cos equals B on A. So now let's have a look at a question. We have to solve this equation, okay? So, a couple of things you're going to do straight away when you see this. You're going to let the marker know that you know that A is root 3, B is equal to 1. It satisfies this equation here. So in my head, I'd be thinking, okay, which equations this satisfy, and write it out. Then I'm going to find R. So R is the square root of root 3 squared plus 1 squared. And that's going to give me square root of 4, which is 2. Last thing then is tan alpha is equal to B on A. So 1 on root 3. Thinking about your triangles where root 3 is, opposite over adjacent gives me this angle, which is pi on 3. So alpha equals pi on 3. Now I can just put it into my formula. So therefore, that's the same thing, and I could write it in the big form. And there I have it. So a lot of questions just ask you to write it in the form R sine x minus alpha, etc. But this one actually says solve, so there's a little bit more to it. So remember, this whole equation we just rewrote in this form is equal to 1. Okay, so now I just solve this trig equation, okay? And you do a lot of these in advanced maths. This one's just slightly harder. So I'm just going to say let u equal x minus pi on 3. Then I'm going to have sine u equals a half. Using my trig triangle again, coming back up here, opposite over hypotenuse is going to give me pi on 6. So u is pi on 6. But then don't forget I let u equal x minus pi on 3, and I want to find x. So therefore, coming up here, x is equal to, x minus pi on 3 is equal to pi on 6. Now it hasn't given me any kind of domain, so I'm not going to test for more answers. I'm just going to have this answer. So then I'm going to have x is equal to, so what do I have? 2 pi on 3 plus pi on 3 is a whole pi. No, sorry, 2 pi on yes, sorry. Pi on 6 plus 2 pi on 6 gives me 3 pi on 6, which simplifies down to pi on 2. So there's my answer. I've solved that equation for x. So it depends on what the question says, but you could have to, stop once you get to the step here and you got it in the form, or you might have to solve the equation. But it's really straightforward if you know your trig equations from advanced well, and then you just remember these formulas. So let's have a look at this. This one is an example where they want you to write it in that form. It was in 2018 paper, worth 2 marks this time. So again, I'm going to jump straight in, find B, find A, find tan alpha, and sub it in. And there I have it. A, B, tan alpha, finding R, throw it into my formula, and I get my answer there. So it's not too bad at all. And I leave it there. One thing I will just note is the domain here wanted only between 0 and pi on 2, and pi on 3 is within that domain, so I didn't have to go any further at that point there. Last thing I wanted to look at then that comes up here and there are your general solutions. A lot of the time, and you can see I've copy and pasted HSC questions here, they're just asked in multiple choice, and it's just about, again, using formulas. So I'm fairly sure if you do look at your reference sheet, I think from memory you do get some of these, if not all of them, but definitely double check that. Okay, I'm going to start with the one on the right just because it's a little bit easier. But basically it says if sine of x equals k, then it can be written to find the solutions for x, you can do that formula. If cos x equals k, you can do that formula, and tan x equals k. Don't forget k is just some number. Alright, so let's look at, I guess they're not too much different from each other, but let's look at this first one to start with. The second one. So when I look at this one, I can see straight away up here that it can be written in this form. So the first thing I'm going to do is I'm just going to write that out just so I know what direction I need to head in. Okay, so we have to find which one of these it suits. Now, this time they don't just have sine x, they have sine 2x. So instead of x equals, I'm going to have 2x equals. Now, n is just whatever nth answer we want, so we leave it in terms of n. Now, alpha. Now we just think back to our trig triangles, thinking about what solution that will give. Pi on 6, but don't forget, so now I've got my pi on 6, it's negative, so I'm going to make it a negative pi on 6. Now, I think to myself, alright, well that's none of those answers, all my answers are in terms of x, okay? And notice too, they don't have a negative in the angle there, which means I need to somehow get rid of this negative. So what I'm going to do is I'm going to divide everything through by 2. A nicer way, in my opinion, of thinking of that is times everything by a half, okay? When I do that, I'm going to have x equals n pi on 2 plus, now this is all one term because it's all timesing together, so minus 1 to the power of n timesing by negative pi on 12. So now I'm much closer, but once again, they don't have the negative there. But think about this. That's really the same thing as timesing by negative 1, which is the power of 1, timesing by pi on 12. So now I have the same term. When I'm timesing two terms together, I add my indices. So that's going to give me the final answer of -1 and +1 times in by pi on 12. And there's my answer, D. Okay, let's look at this first one now. Again, there's just one small step you need to do before you can get to the form, because remember, all of these formulas just want sine x equals some number, cos x, tan x equals some number, where this one's got some sort of ugly quadratic looking thing. Hopefully you can see straight away with a question like this, you're best to make a substitution. So let's have a look. A substitution, for instance, let u equals sine x. And when I do that and solve the equation, I should get... Okay, so, I mean, everyone solves quadratics differently, but here's my solution to the quadratic. I get that sine x equals 3 and sine x equals 1/2. Now, you should note that the sine graph only ever fluctuates between 1 and -1 without any transformation. So therefore, this one has no solution. It never equals 3. And this one here, looking at my trig triangle, x is pi on 6. So now I have my values that I need. I'm just going to sub it into my formula, okay? So I need to find, now with this here, that's just how I found the solution without using the formulas here. But basically now the questions suddenly become, instead of this quadratic, it's now just simply this question: find the solutions for sine x equals 1/2. So now, once again, I'm just going to sub it into my formula for sine. And there we have it, my answer. Okay, so hopefully that helps, makes things a bit nicer for you. Please be ready for one, because they are asked very often in HSC.